Well, we're back at it. See some machines in here behind me. Work. But I thought what we'd try to do is make a new shaft like this one out of that. I got it set up in here. I've already faced this off, center drilled it. And like always, test it before we run it. So you can see on the screen here, it made its roughing passes clear. Here's our profile pass. And then a grooving pass. I'm not going to completely cut this shaft off so that the tailstock doesn't jam it down and seize the shaft up on the tool. So I don't know how well this is going to film because, well, the light in this machine doesn't work very good anymore. If it's even on. Well, it tries to work. Alright, let's get set up for this. Alrighty, let's give this a go. I don't know how far we're going to be able to get with this. I don't think there's enough clearance for this tool. But let's give it a go. I'm not even for sure how much you're going to be able to see. Stainless steel, so we need to run coolant on this, which will make it even harder for you to see what's going on. Yeah, it's pretty dark in there. Can't really see anything. How about I bring it back when we can get the door open and you can see a little more. Well, that other tool wasn't going to clear, so we moved to this one. Different profile. I think it's going to fit in there just fine, but I'm going to run a little slower because not quite as much meat to it. Alright, I'll bring it back. So hopefully you can see, got a little more clearance now. Get this door closed. Alright, I ran one finish pass already. Made a couple adjustments. We're going to run it again. I'm try to take measurements here one-handed. I don't know how well it's going to work. $763. $764. $764. So I need to adjust my X by 14 thousandths. And we'll run it again. This should be the last pass. I made just a little bit of an adjustment, and get to cross there, I'll measure it again. Alright, we'll try this again. I don't know how much I bumped at that time. 749.2. $749.7. $753. That's pretty close. I think we're in the range. $877.5. Some of these are just ever slightly oversized for those different pieces to be pressed on. .5018. We wanted 1.5 to 2 over for that drive gear to press on right there. I think we've done excellent on this shaft. That'll look pretty nice in there. Last thing is bring in the grooving tool. Check it. Looks like it's ready. What do you think, fellas? I think we did all right. I debated back and forth in my mind whether to run this shaft in the manual lathe or the CNC lathe. And finally, I decided to go with the CNC lathe because I want to expose you guys to some different ways of doing things. Uh, and I feel like I was going to get a better finish with the CNC lathe. But really, I thought this would give me a good opportunity to expose you to the CNC lathe and to a little bit of G-code and how that works. So let's jump in here to the G-code now, and so I can explain that to you a little bit. So in this highlighted area up here, we start with a little bit of a header, and that is what is going to create the file on the CNC machine when I copy it over. And then after that, this block is just some various notes for in the future. Not that we'll ever probably run this shaft again, but more so I could give you a good example of how a real CNC program might be started out with some header information. So we have the program name, the programmer me, what this job is for, and then what revision and the date that the program was written. Then a couple more notes. It requires a tailstock, so the operator would know that he needs to use that. And then telling us what the material is going to be. And that could be
in this case 416 stainless steel. Somebody might want, say, a lower grade of just carbon steel 1018. That's just an example here. On to the next slide. I have it labeled as setup machine, and what that's going to do is give the machine some defaults to go with. I tried to put some good notes in here on each line in case I miss something in this narration. You can pick up on what's going on. This first line, this G50, that's setting the max spindle speed to 1500. That just kind of keeps the machine from running away. Uh, Absolute mode, that means that we're going to start at 0 and we're going to just count up from there each of our different dimensions. And then G95 is our inches per revolution mode. That is, for each revolution, the cutter is going to move a certain distance. There's also inches per minute mode. And you might use that if you're not turning the spindle for whatever operation. And then this next little block just ensures that the turret's moving back to the home position before it ever starts anything. So moving on, in this section, this is our roughing cycle. So we set it up with a few things. I got the tool named here. And then we're specifying 450 surface feet per minute. I think I've talked in the past about how you calculate that. I determined that was a pretty good rough number on what was going to give us a good finish on that shaft. M3 tells our spindle to turn clockwise. And then we're selecting tool 6. Then we use a G0. We're going to wrap it into the edge of the part. And then G1 starts our actual cutting, and we're cutting at a feed rate of 10 thousandths per revolution. M8 turns our coolant on. Then G85 starts our canned cycle. On an Okuma, they call it a lap cycle. I kind of broke this up and did 2 different canned cycles or lap cycles just to make it a little faster and easier for me to program for myself. No other particular reason other than that. And I think down here at the bottom, I threw in 1 extra pass, just kind of a cleanup, because it was only 1 single pass and it didn't need a canned cycle. So then we kick down to our finishing pass. Starts out pretty much the same as the roughing pass. We selected tool 7. And then moved to the front of the part, turned our coolant on and such. And then you see a whole list of numbers. You see a lot of Z and X moves. These are essentially just coordinates of all the different places where I want that tip of the tool to be. You could kind of think of it a lot as being back in algebra and geometry classes when you're graphing points on your, well, I guess you call it a Cartesian coordinate system. But really, it's like being on your graph paper and graphing your different points that you've calculated. Real similar to that. Then down at the bottom, go back home, turn the coolant off, stop the spindle. Then our last section was just bringing in that parting or grooving tool and putting that little groove in. Pretty much the same thing over again. Select your tool, select your speed, and then bring it into your area. And we just made a little cut, backed it back out, sent it home and turned everything off, and hey, our program was done. So I was hoping that for you guys to give you a little insight on something maybe you haven't ever seen before, and maybe thought was really complicated, and it turns out maybe it's a little simpler than what you thought it was going to be. All right, let's move on to the next part.
Back on the water pump shaft, I went ahead and lopped that other part off the bandsaw. I didn't think we needed to record that. I just want to take this nub off and get it down flush. That 416 machine's really nice. Yeah, I got the aluminum beer can in here. Probably not Squatch approved, but the aluminum should do a good job of cushioning that stainless from getting marred up on that bearing surface. Not sure how well you can see it, maybe blocked by the chuck, but we got a center drill in here. We need to poke a hole in this. Let's get her going. Man, that 416 is smooth. Well, we got us a center hole. Next, we need to drill till we get to that line. Shouldn't take too long. Call that good. Alright, got this pin. Put a little Loctite on it. Let's give her a little tap, tap, tap. If you remember back to the camshaft, we had that hardened bolt in there. This hardened pin's doing that same job. Something for the thrust adjustment screw on the front of the timing cover to hold that. So that step's done. Alright, here's our setup for cutting the key seats. I got this collet block with a 3/4 inch collet in there to hold it, and the vise, and then we're hung out here, a little bit of a V block. I put a bunch of aluminum in here because this is a hardened V block. This 416 is pretty soft. Some more aluminum up here to pad this clamp. And we got this indicator on here. It's a cheap one. This should get us close enough. So we're right there at 0. Come around here to the back side. It's kind of dark. Going right up to 0. Get the flashlight. And of course the flashlight fell. Alright. I'll see what I can do for rounding up some end mills, and we'll start cutting some key seats. Alright, we're ready to cut the first key seat. I'm set at about 85 surface feet on that cutter. It's a 3/16 cutter, or 1875. I got a little cheat sheet over here with some notes on it so I can remember all the numbers here. So I need to go 106 deep. We'll make this right around 3/4. The length, it's not real important. We just got to get a key in there. So let's give it a try. I'm going to move in the X and the Z at the same time as best I can. Here we go. Alright, first key. Next. This will be about the same. Alright, that's 2. I had to reposition things just a little bit for you. This clamp was in the way. And then on that side, the clamp was blocking the camera's view. So hopefully we can get you in there and see a little bit. That's 3. I'll show you the mess on the floor. Actually, I wanted to show you this dial here. This starts at 0, counts all the way up to 100. Well, 0 is 100 again, 100 thousandths. So we just went 103 on that last cut in depth. All right, last one. Let's give it a try. There she is. Next step is to drill a cross hole so we can pin that impeller in place. I've rotated the shaft 90 degrees and line this up. It's going to be a 3/16 pin. First thing we're going to do is take the center drill and spot it. Alrighty, I gotta go find a drill and we'll come back and drill it. 3/16 drill in, let's do it. And there we have it. Now I'll take it out of there and deburr it. Should be it for the shaft. Alright fellas, here's our shaft. Cross drilled. Key seats put in it. Alright. Well, I think next time around we'll get this hole put into here. And we'll work on getting the keys put in, the keyways put in. We need to go in here. We need to modify a gear. And then I need to decide whether to reuse or replace a coupler that goes down here. So I hope you guys enjoyed this episode, and come back for more Shop Time with Dave.